here's the solutions video to the practice sheet that you guys are working on. It's a combo of the sine and the cosine sum and difference formulas. So let's work through these. All right, number one, x and y is in quadrant 1. Sine of x is equal to 1/2. Sine of y is equal to 4/5. All right, if I want to know the sine of x plus y, I know that that is the formula that we just learned, which is going to be sine, cosine, cosine, sine. All right, sine x cosine y plus cosine x sine y. I can plug in what I know. I know that the sine of x is equal to 1/2. It's a horrible fraction. And I know that the sine of y is equal to 4/5. Put my plus sign there. Now I need to go ahead and figure out what the cosine of y and the cosine of x are. So I'll come over here and I'll use my Pythagorean identities. I'll do the x's first. Sine squared x plus cosine squared x is equal to 1. I'm plugging in 1/2. This gives me 1/4. Oops, plus. When you subtract, you get that cosine squared x is equal to 3/4, or that cosine x is equal to plus or minus the square root of 3/2. And it says that both of mine are in quadrant 1. In quadrant 1, my cosines are positive. So when I plug in for the cosine of x, I'm plugging in positive the square root of 3/2. Then I can do my work for my y. Sine squared y plus cosine squared y is equal to 4/5. And yes, I do expect to see all of this work on your papers, your homework, your quizzes, whatever. I want to see it. Ooh, why am I writing 4/5? Should be equal to 1. Oops. So this is going to be 16/25 plus cosine squared y is equal to 1. So I get that cosine squared y is equal to 9/25 when you subtract that over. So cosine y is equal to plus or minus 3/5. And I'm in quadrant 1. Both of mine are in quadrant 1, and y's are positive in quadrant 1, so this is going to be positive 3/5. Then I can go ahead and multiply. 1 times 3 is 3, 2 times 5 is 10. The square root of 3 times 4 is just 4 times the square root of 3 over 10. Common denominator, so let's smush them all together. Final answer is going to be 3 plus 4 times the square root of 3 all over 10. Boom, baby. Number 2, B is an acute angle. All right, in reality, the Regents exam would not give you this little tidbit, but I did. Again, the sine of B is 12/13. Find the value of part A, the sine of 90 minus B. Oh, I didn't give you part B. Okay. So, writing out this formula. All right, don't get thrown by the 90. This is just the difference formula for sine. So, I know that this is going to be sine, cosine, cosine, sine. All right, sine, cosine, cosine, sine. The middle signs change the same. All right, and actually when we plug in what we know, we can actually plug in a lot of stuff. All right, they gave me that the sine of B was 12/13, so that's nice. Okay, but I also know what the cosine of 90 is. And I know what the sine of 90 is, right? 90 is a quadrantal, and if we look at the unit circle, here I'm at 90 degrees. This is the point 0, 1. So the cosine of 90, the x-coordinate is 0, and the y-coordinate, the sine of 90, is going to be 1. All right, so for the cosine of 90, I can just plug in 0. And for the sine of 90, I can just plug in 1. And now I do have to do a little bit of legwork and use some Pythagorean identities to find the cosine of B. So over here I've got sine squared B plus cosine squared B is equal to 1. So the sine of B is 12/13. So this is 12/13 squared plus cosine squared B equal to 1. This gives me 144/169. plus cosine squared equals 1. Let's see. 1 minus 144 divided by 169. Whoops. That is going to give me 25 over 169. Sorry, I had to get my calculator. Square root both sides, you get that cosine of b is equal to plus or minus 5/13. But I'm in quadrant 1, and cosines are positive in quadrant 1, so I only want 5/13. Almost forgot my minus sign. Okay, and this is nice because 1 times 5/13 is just 5/13, and I don't care. And over here, that's times 0, so I don't care because anything times 0 is 0. So that right there is your final answer, 5/13. Okay. I made up for that only having a part A because here you have 4 parts. All right, here is all of the formulas that we have learned thus far. So we got a couple ways. What I'm going to do is I'm going to go ahead and I'm going to write down all of these. All right, so for the sine of A plus B, that's going to be sine, cosine, cosine, sine. All right, so I filled in that formula. Here it's cosine, so it's going to be cosine, cosine, sine, sine, sine. All right, the sign changes. Here I'm at sine again, so it's going to be sine, cosine, cosine, sine. All right, it's going to stay a minus. I'm squishing, I'm running out of room. And then for cosine, this is where it changes, so it's going to be cosine, cosine, sine, it changes to plus, sine, sine. Okay, so I got that out of the way. Now I can go ahead, plug in stuff, figure out what I need, and I'm going to go ahead and I'm going to just plug in what I know so far. So I'm going to plug in the sine of A and the cosine of B into all of these formulas. So for the sine of A, I'm going to have 3/5. Cosine of B is going to be negative 15 over 13, or I'm sorry, negative 5 over 13. Erase that, make it look nice. Negative 5 over 13. And then that'll be a plus. Here, sine of A is 3/5. Gonna have this minus in front of it, and then I've got the cosine of B right here, so that's negative 5/13. Alright, it's kind of nice to just go ahead and fill in all this stuff so you don't have to do it all again later. So there's my sine of A, I'm gonna have a minus, here's my cosine of B. Sine of A, you're over here. And then I've got my cosine of B right here. Alright, there's the busy work. And now, I'm going to scroll down a little bit just so I can do my Pythagorean identities. Okay? So let's go ahead and find all this stuff that I'm missing. I'll do the A's first. So sine squared A plus cosine squared A equals 1. This is going to be 3/5 squared plus cosine squared A equals 1, which is really 9/25. Plus cosine squared A equals 1. Subtract that over, you're going to get 16 over 25. Take the square root of both sides, you get that the cosine of A is equal to plus or minus 4/5. And A is in quadrant 1, and in quadrant 1, my cosines are positive. So the cosine of A is going to be 4/5, positive 4/5. So I'll go ahead and plug that in everywhere. I'm over here, and I'm over here. Beautiful. Okay, and now I'll go ahead and I'll do my Pythagorean identity for the B's. Alright, so I've got sine squared B plus cosine squared B is equal to 1. And I want to find sine, so sine squared B plus, and then cosine of B is negative 5/13. So I get that sine squared B plus, this is really 25 over 169. So I get that sine squared b is equal to 144 over 169. So really sine of b is equal to plus or minus 12/13. And b is in quadrant 2, and sines, which are my y values, are positive in quadrant 2. So this is just positive 12 over 13 that I'm filling in everywhere. Boop. Getting a little cramped, I'm sorry. And then I can go ahead and for part A, this is going to give me negative 15 over, what's 5 times 13? 5 times 13, 65, plus 4 times 12, that's 48 over 65. Why are my pens doing this? 48 minus 15 gives you 33. So this answer is going to be 33 over 65. That's for part A. For part B, I'm going to get negative 20 over 65 minus 36 over 65, which is going to give me negative 56 over 65. So that's the answer for part B. For part C, you're going to get negative 15 over 65 minus 48 over 65. And that is going to be, oops, if I could type, 63 over 6, negative 63 over 65, I'm sorry. That's the answer for part C. And then over here, this is going to give me negative 20 over 65 plus 36 over 65, which is going to give me 16 over 65. Notice, none of these were the same thing. Okay, so this really shouldn't have been too bad because, like I said, these identities are on your reference sheet, that pink one. Make sure you hold on to it. And then, besides doing this Pythagorean identity work right here, you're just plugging and shoving. All right, hopefully that was not too bad.